Hi, I'm Gabriel Santos.
And my name is Hunter Kepon.
And together we're the team Huntriel Sampon working on the image watermark extraction.
So for my part of the project, I performed some research and we discovered that in order to determine where the watermark is on the image, we needed to write a seed growing algorithm. And then our first attack method was the color change, and I worked on that to figure out how to change the color, the area of the watermark to match the color of the image behind it. And then we used a discrete cosine transform on the image to change the intensity of the image color in that area. And then I created a coordinate system for our blur function.
Right. So along with all the research I did as well, to tag along, the blur code is the third attack method that pretty much smoothens out the final touches of the image that are pixelated. And the pixelation is caused by the first two attack methods. It's optional. And then I also took care of the aesthetics as well as the debugging of the program, meaning I made it as user-friendly as possible.
So the first thing we did was determine the area of the watermark, and we did this by having the user define some points inside the watermarked area, and then those points form an average, and then each of the points checks the 8 surrounding pixels around it and adds them to the watermarked area if they are within the range that the user defines when compared to the average of all the watermarked area.
Right. Just like it sounds, you plant a seed with your points and then it grows according to the averages.
And then after that, once the area of the watermark is determined, we implement our first attack, which is the color change. And to do this, we have the user select points that represent the color that should be behind the watermark. And by this, we change the color of the watermark and make it match the image. And then we also do our discrete cosine transform of the image, and this allows us to change the intensity of the watermarked area. So if we want to make it a little brighter or darker, that's where this part comes in.
Yes, and there are further instructions on the README as well as the actual program itself. And so after the second attack method, you have an option to implement the third, which is the blur. And like I said, it smoothens out the remaining parts of the watermark that seem a little distorted. And so this puts the final touches.
And the way we did this was to have the user define opposite corners of a rectangular area, and then that area is removed from the picture, blurred, and reinserted into the picture.
Yes, and so after Hunter and I were able to make up all the code that is able to extract the watermark, I went back and I tested it like a beta, and I made sure that everything was user-friendly and incorporated all the instructions. So why don't we get to the demo? Okay, so
So open the project and then you input the file name that you want, including the .jpeg extension. Then it's going to ask you for some seed points. So when you're placing your seed points, you want to work on an area of the image that has similar background color in the original image. So I'm going to choose to work on the COP. So I just select the points within the watermarked area, and then it asks you for a deviation limit. So the higher your deviation limit, the more points it's going to allow into the watermarked area. So I'm going to choose 0.13, and that's pretty decent.
Yeah, so I'll just talk along while Hunter's going. If he had chosen something a little lower, he might not have grabbed the entire C, the O, and the P. So you want to just work with it until you get everything you want.
And here the user is allowed to just play around with it until they get as good of results as they want. And so now we define points outside the watermarked area. These points are used for our first attack method, which is the color change. So the points I'm going to choose are going to be ones that represent the color of the original image underneath the watermark.
Note that Hunter's clicking part's closest to the watermark. That's pretty average.
So that worked pretty well right there, and that was our first two attack methods, the color change and the DCT. The color change was done with the sample points, and the DCT was the coefficient that the user entered. And so say if that didn't come out as well, maybe the COP was a little bit darker than the surrounding area, I could have entered a coefficient at like 0.9 to just decrease the intensity there a little bit and make it match better.
Yes.
And once again, the user has complete control over that.
Yes. So you can either continue to work on more parts of the watermark, which we'll do.
Continue.
Yeah, continue. And so you now have your COP gone, and you can work on something else.
So I'm going to do a little harder area, the 2008. This area has a bunch of different
Shades,
colors
yeah.
behind it in the original image, so it's harder to gather that area. So right here I'm clicking points that are representative of the complete area I'm trying to get.
Right, so he doesn't click on the part of the 0 on the coil because that'll disrupt the average because it's a lighter kind of grayish color. He doesn't even touch the 8 because the 8's on a whole another shade as well, and so we're just going to work on the parts of the watermark that are of similar qualities, if you will.
So here it got most of it. I might want to try one higher just to do a little better.
Yeah. Note that you have two figures, one with the watermark in white on the original and then just sort of like a blacked out so you can see exactly what you grabbed. Both are pretty helpful.
And there, that grabbed a lot more of the points, so we'll go with that. Yeah. So now that you have that, you move on to the color change attack method. So here, this part's pretty
important.
Crucial here. You want to select points that are gonna be representative of what colors are behind the watermarked area. So I'm not gonna click on the red part here because none of my watermarks really covering that. I'm gonna click these dark colors.
You notice how Hunter's more meticulous about clicking these points than he was with the CO and the P? That's because the concrete is all pretty much the same type of gray. Whereas on the motorcycle, the part that the 2008's on, it's on a, like this, there's not as much range, so Hunter has to click more specific points to get a better average.
Now when you're selecting the coefficient, you generally want to start with 1. That seems to work pretty well. But
it really depends on how well your outside watermark points are.
So that result there was very good.
Yeah, very good.
And we'll use that.
Yeah. So we'll finish just for the sake of time. Note that the user can cover the entire thing through the exact process we just went to.
Now we implement the blur attack. So here the user clicks opposite points on the area that they want to blur. So I'm going to choose this little coil area, and I'm going to get that area right there. So you can see the effect.
Yeah.
It really cleans up some of the pixelation.
Yeah. You can hardly even notice the blur. That's why it's important for the user to be able to blur only certain areas as opposed to the entire picture, because if you blur the entire picture, yeah, the watermark might be gone, but then the original state of the image, it looks way more distorted that way. So yeah, Hunter's coordinate system helps.
And then you can just continue blurring until you're satisfied.
Yeah. Now the 2 looks like it's part of the fender.
And that is really the scope of our program.
And end. Yeah.
Thanks for watching.